Okay, so here it is. Interpreting functions. Now you're gonna see uh, kind of like real life scenarios and models where they use functions here. This function notation, and all you gotta do is be able to read it and interpret it and understand what's happening. Okay, so what does it say here for number one? Let h of t. They're using h, right? Again, they can use any letter they want, but they use h because we're talking about height. So that's the h. T is going to stand for something, right? Usually we use x, but see, we're using different variables. Let h of t, this function of h of t, represent the height, right? I said that already for the h, which is in feet. Sometimes it can be in miles or inches or whatever. It's in feet in this case. Height of a model rocket. Like those little model rockets they shoot up in the air like that, right? They launch up in the air, these model rockets. So we're going to have this rocket that's going to obviously leave the ground, shoot up into the air, and obviously it's going to fall back down. Okay. Of a model rocket after it has been launched and what does the T stand for? T stands for time. Oh yeah, okay. The H is for the height, the T is for time. But the time is in what? You gotta watch out. Later when you get into chemistry or physics or biology or anything like that, some of these formulas, your time is in minutes or it's in seconds or it's in hours, you gotta watch out. And if it's not, you gotta convert. But this one you don't have to worry about. You don't have to worry about that. This time here is in what? In seconds, right? It's not going to take like minutes looking at this just simple little model rocket, right? We're looking at a simple model rocket. Okay, so let's go ahead over here. Go down here, I left this blank for a reason again. So what is this H? Go ahead and write on it, right here. What does the H stand for? Height. Yeah, go ahead and write that. We understood that. Sometimes you got to read some of these like 3 or 4 times until it starts sinking in and you start seeing what what everything means, right? The H is for the height, that's what the function is. And the T is for what? For the time. Oh, I forgot to say something. The height is in what? Is in feet. Let me put that in parentheses. The height is in feet. And the time is in what? Seconds. Copy this, Jaden. Okay. Now, what did it say in this phrase, in this sentence, that this function is going to tell you? What does h of t equal? Huh? What does it mean? I wrote it. I'm just asking you again. What is h of t? What does this function is according to what you understand so far? This function of h of t is going to represent what?
How high is the rocket?
How what?
How high the rocket?
The height. The height of the rocket. All right? I know there's other little variables here. Okay. So that's what this function is right here. That's what it's kind of saying up here. It's saying the same thing up here, but I just want you to know that the h of t is equal to the height, where this part is the height, not this part. You'll see that right now. This answer on here's the equal sign, right? Here's the equal sign right here. Here's where you're going to get your answer for the height. The function, though, the value of t that you're going to be substituting here is going to be what? Seconds, right? All right, so here's the thing. So you understand that the function, we're talking about a rocket, and let's just do this for a bit before you start explaining, all right? You're going to see after this quick little visual breakdown, it'll make sense. Let's see if anybody just is good. Can tell me. Can anybody tell me what this means? Oh no, not that one. Let's just go with the first one. Can anybody tell me what this means? If you understand this function, and you understand what the situation here is, what does h4 equals 30 mean?
The height was 30 feet and it was 4 seconds.
Can you say that again, please?
The height was 30 feet and it was 4 seconds.
You guys understand that?
Yeah.
Great, that's it. That's what this is saying. That is it. That's what this is saying. Because this is the function for height, right? And you got to know what this number means. Remember we talked about input and output and understanding things? Hold on, what is this? Better be spam. This is not even a number. Let's see. Hello?
This message is
Goodbye. Okay. All right, that's it. That's what's going on here. That's that easy. But let's check this out. Let's do a little, go ahead, and I left a little open space right here. Go ahead and do this, please, for me. Go ahead and put kind of like, we're going to do a little, kind of like a little visual here, a little drawing like this, yeah? We're going to go ahead and, does everybody agree that like when you launch a rocket, it's going to make like an upside down U shape like this? It's not just going to go straight up and come back down. Everybody agree that if I launch a rocket, it's going to kind of look like this, like, it'll be like this trajectory kind of a thing like this? Yeah, go ahead and just draw that in like that. Right? And just so that you just have a deeper, better understanding of everything that's happening here. Now, we're going to label our axis. See, in math, you got to understand, and we just talked about this. Remember, data and information, things can be presented, right? We saw relations. We saw coordinates, we saw tables, we saw graphs, we saw mappings. There's this understanding, and understanding mathematics is, you can represent it in different ways. That's what's happening here. So down here, this one says in 4, isn't this the time? 4 seconds? 4 seconds. After 4 seconds, right, the rocket got launched. 2001, 2002, 2003, 2004. After 40 seconds, it was what? What does the 30 mean? It was 30 feet up in the air, yeah? I just made up numbers. I don't know. Okay, you got it. You already understood that. That's what it means. After 4 seconds. So how would I put this over here on this graph, on this little thing we're doing over here, this little visual? Well, let me just put a 4 right here. Right? Because this bottom line is seconds, right? Which is actually t, right? This is actually t, right? I put it too close. This is actually our t. This axis here, right? Instead of x and y, we're using t for time. After 4 seconds, it was what? Oh, let's say it hits right here. After 4 seconds, it was what? 30 feet. So this is 30, and then this over here is what? Feet, right? This is feet. Or this is the height, right? The height, but it's in feet. Okay. Who can tell me what this one says? What does h10 equals 84 is? According to your understanding of this function and looking how it is right there, what does h of 10 equals 84 mean? Oh, that's it. I told you this was easy. See, once I explain it, it's so easy. This is after 10 seconds. What does that mean? That when I put 10 in there, after 10 seconds, the height is what? 84 feet. That's easy to understand. You see, math is easy when you get it. Like when it makes sense, you're like, oh, that's it. I'm like, well, yeah, that's it. But when you guys first walked in here and you saw this worksheet, you're like, what the heck is that? Is this for us? You thought it was probably for my pre-calculus class. No, that's it. So let's put that here. So that's 4. So 10 will be like, this is 4, so another 4. So like 10 would be like about right here, maybe in the middle. Everybody agree 10? After 10 seconds, that would be up here. It hits right here, so that means that would be what? 84. Okay. Okay. You guys understand that? You're like, well, yeah, that's easy. Okay. Now I want you to take about 30 seconds and don't say anything. I want you guys to think about this. What is this saying? What is this saying? We understand this picture. We understand the scenario, the situation here, but this one is different. Let's see. Think about what's going on. Who can tell me what this is and make sense of this? Give everybody a second. What does it mean when they're doing that? What is that saying to you? And how does that make sense in our picture here? Okay, hold on, Matthew. Does everybody agree this one is not like these other ones? No, this one is saying that the height, the height after 7 seconds, does that mean that it's 13 feet? Is that what this is saying? No. Who can tell me what this is saying? What do you think, Matthew?
Yeah, the height was the same when it was 7 seconds and 13 seconds.
How is that possible? Can you tell me how that's possible? How is it that the height after 7 seconds is going to be equal to the same height at 13 seconds? Can you tell us that?
Because 13 was to 7.
Because what?
Because 13
Yeah.
has 7. It eventually passes 7, so it's gonna be the same height. Like.
Okay, is there a way you can show me and I can show it on the graph here so people can get it? Jaden? Okay, go ahead, Jaden. What do you think?
At 7 seconds, it reached the point.
So let's put 7 seconds. Let's see if this is 7 seconds right there. Is that about 7, right? Between 4 and 10?
Yeah.
If that's 7 and I go up, tuk, 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 and it hits about right here, I don't know what this height is. I don't know. I really don't know. Everybody agree? I don't know. I know it's between 30 and 84, but I don't know. But how is it that at 7 seconds, whatever this height is the same as 13? Go ahead, Jaden, continue.
So at 7 seconds, it reached the point where it, when going up 7 seconds is, it reached the same amount of feet as 13 seconds going down.
Okay, you're correct. You want to say it a different way, Matthew? Yeah, go ahead.
Because since the rocket goes like that, it goes like a arch, it met at the same point that 7 was at.
You guys understand? Can anybody say it a different way? You guys understand what's happening? Right? Because right here, yeah, at 7 seconds it was this height. Let's say that was like 50. Let's say this was 50. I don't know. But isn't it going to be 50? Okay, and then it's going to go up, and then eventually it's going to come back down, and it'll be here at 50 again on the way down. That's what you guys are saying, right? So at 7, it was right there. I don't know what it is. Let's say it's 50. But then when it's over here at what? 13? It's also the same what? It'll be the same height. Does that make sense? Yeah, that's what this equation or this notation is saying. That the height after 7 seconds is the same height. I mean, I don't know the number there, but it's saying that at 7 seconds and at 13 seconds, it's the same distance from the floor, right? The same height. That's what it is. You guys write that in there. You guys write that in there. It's going to take like a sentence or two. At 7 seconds and at what? 13 seconds, the rocket has what? The rocket is at the same height or has the same height. Does that make sense? Because on 7 seconds, I mean, we can write a whole paragraph here. At 7 seconds, the rocket's going up. And let's say at 7 seconds, it's 50. And then it keeps going up. And then on the way down, by then it's 13 seconds, it's at 50 again. Does that make sense? Yeah. You see, this is easy when you get it. All right. Now talk to me and go ahead and do these last two. This doesn't say whole either, okay? HO equals 0, or H of 0 equals 0, and H of 24 equals 0. What? How is that possible? Somebody tell me and think about that and look at our picture over here and think about that scenario with that rocket. How is that possible? Or what is 0? What the heck is that? You got it already, Jane? Okay, hold on. Hey. Okay, what does that mean? H0 equals 0. That at 0 seconds, which we haven't launched it, right? We haven't launched it. If we haven't launched it, how high is it? It's not. It has. That's what that means, right? At what? 0 seconds. At 0 seconds, what? It hasn't lifted off the ground. There is no height. There is no height. And that's what this other 0 stands for. At 0 seconds, we haven't launched it. We're not going to look up. Hey, where's the rocket? No, it's in the floor. Hasn't left. And wouldn't that be, how would you mark it over here on the graph? Or what would that point be on the graph? Or how would you mark that? Right here. This is 0. At 0, the height is what? 0. That's it. I mean, it's like logic. It's common sense. Like when you understand it, it's easy and it makes sense. Okay. What is that saying? And how is that possible?
24 seconds.
Go ahead. Let me have. Yeah, go ahead.
After 24 seconds, rocket already landed.
At 24 seconds, what happens at 24 seconds? What does it mean that the height is 0? It's already back in the ground, like boom. That's it. That is it. That's what it means. So that's it. At 24 seconds, the height is 0, right? 0, which means what? It hit the ground. It's already like boop. Which means it landed or it hit the ground. And I'm going to put over here, where do I put a 24 over here? Where do I put a 24? Here's my rocket, here's my trajectory. I understand 0, 0. What is this one? What does 24, 0 mean? Bless you, bless you, bless you. So it took 24 seconds? Okay, good. All right, I'm going to change the story, change the scenario, but the concept, the logic, the thinking is the same. Go ahead and do number 2. Go ahead and do number 2. Okay, here it is. Here this one says, let C of T represent the number of cars. Oh, that's the C, right? C is for the number of cars in a teacher's parking lot after T time. Oh, but the time is in what now? In minutes. Okay, I get it. The C is the, oh, let me write it over here. The C is the what? The cars are the number of cars. The T is for what? Yeah, write that in time. But that's in what? Minutes, right? Not seconds. So just read it, what it says there. Okay. And what does this function C of T mean? It's going to tell me the number of cars, right? Cars in the parking lot. But there's another little twist here. Anybody know what the twist is here? At 7 o'clock in the morning. Remember, school doesn't start till 8:30, right? This one says at 7 o'clock in the morning. Why is that important? Well, let's see. What does C20 equals 12 mean?
20 minutes
What
or
else?
12 cars.
20 minutes after 7, there's 12 cars.
Ah, 20 minutes after 7. So after 20 I'm sorry, not 20 seconds. After 20 minutes, so now we're talking about what? If it's after 20 minutes, that means that at what? At 7:20. Ah. Remember, because it's 7, but then this one says 20 minutes after the time. 20 minutes after 7, that's 7:20. There are what? 12 cars in the parking lot. Okay, some people have to open up in the office and the custodian. Okay.
Mister,
Yeah?
do we have a parking lot?
Do students have a parking lot?
Yeah, next one.
Not that I know of. Other schools do, but not us. Hello. Okay, bye.
We said a call.
Huh?
They ended it.
I know. We said bye. Okay, what does that mean?
At 7:30.
So 30 minutes past 7 at 7:30, because then teachers start coming in, right? At 7:30, because it's 30 minutes after. There are what? 23 cars. And I want to see what you put here. You got the last one? Okay, tell me what you wrote.
60 and 65. No, 60 minutes after 7 and 65 minutes after 7 is the same because school already started.
Yeah?
60 minutes after 7, 65 minutes after 7 had the same amount of cars in that time.
So this is 60 minutes, but isn't 60 minutes an hour?
Yeah.
So that's 60 minutes. 60 minutes is an hour. So at 8 a.m. At 8 a.m. there was 65 cars?
No, it's the same amount of cars.
That's the same.
At 8 a.m. and 8:05 they were.
So that means nobody came in within that 5-minute window. It was still okay. See at 8 a.m. and also at what? What's 60? Oh, at 8:05. At 8 a.m. and at 8:05, between that 5-minute window, I don't know how many cars were there, but it was what? The same what? Number of cars. Ah, fácil. Does that make sense? That's what function notation is. So you're gonna see that. You're gonna see that in the assignment. Okay. I think you're good with that. There's an example in the book, right? Because the assignment's from the book. So right before you go to the assignment page, at the beginning of the section, there's an example. There's 2 of them like this, but different scenario, different story, right? But I think you're gonna do good. Okay, last thing for today. I actually showed you this yesterday, but I'm sure with one problem we're gonna be good. Ready? Let me just put one problem here. Ready? Go ahead and put f of x is equal to, what was that problem I had yesterday? Was it 3x minus 4? And I'm going to put the same thing. F of x is equal to 3x minus 4. Oh yeah, I remember this. Tell me this is the one we learned yesterday. If I ask you this, find or evaluate f of 8. You guys remember that one? We didn't write it down. I did it on the board, but we already learned. As a matter of fact, this was your homework last night, wasn't it? Yeah. Okay, so we learned this one already. That's not what's going to be on the assignment today, but this means what? What does this mean? This means that what? X is equal to 8, right? So here for this function, everywhere there's an X, you're going to put a what? An 8. Oh, okay. So f of 8 is 3 times 8 minus 4. Yeah, I can't remember. I remember. Yeah, this is the same one we did yesterday. And you got 20. Remember that? Because that's 24 take away 4 is equal to f of 8. So the function, when you substitute an 8 in there, it gives you the answer 20. We got that? That's not the ones you're going to have on today's assignment. That was the ones on yesterday's assignment. You're going to have them like this. What's the difference between this and now it's going to say this? Find, or it's going to say, actually evaluate when. Now here's where you got, don't mix these up. Here's where you got to know the difference. When f of x is equal to 8. Oh yeah. Is this one saying that x is 8? No. If that were true, the 8 should have been in here where the x is. Can somebody tell me what that one is saying? Nobody knows how to do this one?
That like the equation should equal 8.
I'm sorry?
That the equation should equal 8.
That's a what?
That the equation should equal 8.
So what would you write?
So
8 of x.
You're close. Who else? Dean, you think you got it?
No, I was gonna say maybe you have to like do it backwards. Like
Okay, I'm gonna tell you. Anybody else? Last chance? Because you're gonna say, "Oh yeah, that's what I was thinking." No. This is the function, yes? Okay, I'm gonna write it again right here. Okay. Messed up. Okay. What does that say? Does that say that the x is 8? No, that would be this one, remember? This one says that f of x is 8. Where do you see here that it says f of x?
so 8 equals
This part right here is f of x. What number do I put on this side? 8 is equal to. Ah. That's what I hear. You see the difference? Don't mix them up. Yesterday I didn't have, I used y. Remember I used y in the warm-ups, in the Padlet? It was a y here and it was a y, and you put the y, you put the 8 where the y was, and you were fine. But see, now that I wrote it like this, you guys lost it. You guys see the difference? Okay, now you solve this. How do you solve this?
X equals 4.
Well, it'll be 3x equals 8 plus 4. That'll be 3x equals 12. Okay, so the ones you're going to have today are going to be like this. How do you know when they want the x to be 8? They'll write it like this, where the x is like this. But the ones you're going to see today are not going to say that. They're going to say like this. That means this part, this number is what? Is the 8. Everybody see it? All right.